So basically we have a sine integral function, and oh, sorry. And the problem asks explain a little bit about how you define f of 0, because this is not defined. But we can use a limit value to define the function, so make it continuous. I'll leave the drawing part to you. You can use a graphic calculator and how to figure out the local maximum. Local maximum, we want the first derivative, which is sine x over x, to be 0. That's a critical point. So here that gives us x equals k pi. K is integer, but k cannot be 0 because by our definition f of 0 equals 1 by using the limit value. And if you write, I guess it's fine. And we also want the local maximum, so we also want to check the second derivative is negative. So let's compute a formula for second derivative, which by quotient rule gives us this. So we also need this to be negative. So here basically you just have to check if you plug in k pi, this part is always 0. So basically that's basically the sine of x cosine x. So let me quickly figure this out. When k is even, cosine is positive 1, and we want it to be negative. So here it tells us that if k is even, this is positive. We want this to be negative. So k is either even and negative, or odd and positive. So those are the k that will make this formula. This formula negative, and that gives us a local maximum. So x equals k pi, and k is these possible things, integers. First inflection point, that's right to the origin. So let's open another page. We want to solve x cosine x minus sine x. Inflection point, second derivative will be 0. So that gives us so let me check. We want this to be 0. So we want to solve this equals 0. So you have sine x over cosine x equals x. So that is solving tangent x equals x. This one you don't have the analytic formula, but you can estimate it by using the graph calculator. and I'll leave that part to you. Does this function have horizontal asymptote? So when x goes to infinity, does this converge basically? Not pi over 2, but infinity. No, here should be x. Sine t over t dt. So horizontal asymptote basically asks you if this integral does this integral converge. I'm not sure if there is a good way to do it. Maybe you can use the graphic calculator to see the graph and to make a conclusion. But the answer is yes, and you will know how to compute this integral from a more advanced class. If I remember correctly, the answer of this limit should be pi over 2, but you're not going to do this in this class. If you're a math major, you might learn it in a more advanced class, or for the purpose of this problem, you can just use the graphic calculator to see it. And I'll leave the last part for you by using the calculator.